Alright guys, I'm actually going to make a video of this time. Last time I didn't even think about making a video until I already had it finished, but I'm going to explain how to redo the voice coil. If you got a speaker that's blown the voice coil, burned out the voice coil, the windings on this, you can redo it yourself, but it can be a pain depending on what the style of basket is and stuff. So this is what I started with. These were good speakers till I eventually blown them out. Had two of them. Now on this, so this is how these go, right? They've got this plate, and they got these they got bolts that go up from the bottom into this plate, you know, and you can't get to it except what I did is this style of basket had like bars that went down, and I just took a Dremel tool and opened it up so there's a square there so I can get my finger in and tools in and get to these screws. Now these screws, they go into this plate and they're really short, and they got a Phillips head on them, right? Not like these. What you do is when you initially get the Phillips head ones out, and it's going to be a real pain in the ass. Once you initially get them out, then you can go to Ace Hardware and buy you some hex head ones, and then you can rebuild the speaker as many times as you want, as long as you're careful. So these are, I found them that fit the actual threads and stuff. They are, what were they? 6. I'm pretty sure they're 6. It can't be 4. They got to be 6 millimeter. The top head cap is 8 millimeters, so they got to be about 6. And whatever the normal thread is, they're nothing special, but you can just bring the plate to Ace Hardware and try them until you find the right one. And then your problem is getting the shortest ones you can. Sometimes that is because if they're longer than this, the next thing that goes on there is your magnet, and that's like a dead end for that hole. So what I ended up having to do was I had to buy, these are the shortest ones they had, so I bought these all to replace them with, because that screw head is a pain, and you'll have a huge amount of trouble getting it off. If you had this is like it's broken. It was like Z-shaped, and it had a Phillips head on each side before it got broke. But yeah, these are little tools that you do something to do with adjusting drum brakes, I think, or something. But I'm not sure where I got these, but I had 2 of them. But you get these up in there to unscrew. You can't get any type of ratchet in there. Is way too small, you know, obviously. So what you do is you get one of these Phillips things like this, and you gotta take one of these, and then you take the 1/4 inch and you go like that, and now you got a 90-degree screwdriver. And what I did was I epoxied this onto an old screwdriver, and then you can get that in there to get them loose initially, and it's a real pain. You can only go a little bit at a time, but once you get them broke loose, because they're Phillips heads, and you get them broke loose, and then what you do is, oh, you got one here. That's the then you can just get your needle nose in there and go like that until tight, loose, and it takes you forever. But once you finally get your initial stock screws out of there, the Phillips heads ones, then from there on you use the ones you bought. Even if you got to use 3 washers to get them the length you need, which is what I'm going to have to do. I lost my washers. I'm going to have to dig them out from somewhere. But yeah, you got to have your washers because you can't find them that short. And then next time you go to rebuild it, you can do it easier every time. So that's the gist of it. I had to cut these out, and then now you can find this specific style of basket. It's pretty common and with these the bars that went down, I just cut them out. And this one I know for a fact you can get apart and rebuild. It's not the easiest, but it's the easiest one I've found. Really, it's the only one I've actually tried with, because this is just the first ones I ran into. So, but these work if you got this basket. So your magnet goes next, and then you've got a back plate. Now what I've done is, see, now the reason I'm doing this video is because my last try, when I showed it all put together, I had made a mistake, and I had to redo it. The mistake was that when I made my coil former, I forgot to put a couple layers of masking tape on to make the gap. So it's oversized by that amount, and it was just a hair too tight. And this is your back plate, and your back plate, wow, yeah, there's some weird things this magnets does. It'll catch everything. Your back plate has to fit in there nice and loose. And my last one was just way too tight, and I tried sanding on it, and I had to give up and start over. I wound a new coil. Now this is, if you go to Ace and you look at their duct work for, really what it's for is like the exhaust for a gas water heater, the exhaust ducting that goes out the roof, and it's aluminum. You find this aluminum, that's what it's for, and you can get a big sheet of it for super cheap, and it's the perfect thickness for making your coil former. Now what I did was I just put, like, 4 or 5 layers of masking tape to give it a little extra thickness out, bigger than this, and I wrapped it around. I cut it to length, and I used zip ties to hold it in place, and then I started winding it. Now this time I'm doing something a little special here. Obviously I'm using 2 magnets, which it did not come stock with. It's my first time trying with 2 magnets. I rebuilt it with just 1 magnet like it was from stock once already, and it worked for quite a while, and then I burned it out. And the reason I burned it out was I used, for the glue to hold this together and hold the windings together while I wound it, I used just regular epoxy, right? Well, it got to a point to where there was, well, for one thing, I put way too much epoxy on the first time anyways. I had like a thick layer of it, right? And this time I did it better, just as thin as you can get it, and still have enough to be sure it's going to hold good. And they usually want to start coming apart from the end, like the first couple millimeters of this coil like gets stuck in the end or something. So what I did this time is I used this. You got to get this, the high heat epoxy. So 550, that's like, it's like about 260 or something C. Whereas, and this time I went with 26 gauge, and they actually had an option for 240 C instead of the regular temperature, higher temperature one. You never want the red coating. The red coating is the low temperature. You get this brown. I always get Remington. That's what I always use. And then the brown coating one is the higher temperatures. It's over 200. I forget what the next one up is, but this is even higher. You don't see the 240 very often, but they had that option, so I bought it. It's usually like 220, I think. But yeah, 240, and I'm using 26 gauge. Normally what these speakers almost always have is 28 gauge, which is just slightly smaller, and I'm doing a little test with this, right? So normally they'd be 28 gauge, and normally with the 28 gauge and a 2-inch voice coil, this will have a width of about 20 millimeters. And the reason being is all wire is rated, let me show you. It's rated at DC resistance, ohms per 1,000 feet. So at 28 gauge, it is 40. Let me get the cursor out of the way. 64.9 ohms per 1,000 feet. So you got to calculate that out to where you want your 4 ohms. You got to have that amount. And you calculate that out to get your 4 ohms by this manufacturer's ohms per 1,000 feet. So then you know how much actual wire needs to be wrapped. And then you calculate that. See, now I went with the 26, which is the next odd one up, which is quite a bit difference. It's 40.8 compared to 64.9. And the thing is with the 26 gauge that I got, I'm not going to get a 4 full ohms or a whole 4 full ohms. I'm going to get less than that, and I'll show you. Well, for first reason why is I bought this roll of wire, and it wasn't cheap. It's a little extra because it's the higher temperature one, and I didn't think I was going to be able to wind that much. I thought I used so much when I messed up the first coil that I was guesstimating by my calculations that was all I was going to have. So I could have went a little more if I knew I had this much. I was going to have this much wire left over, but so yeah, that's because I messed up the first one. So I did with 25 millimeters and 2 layers, starting here, wind up to here, and then wind back. So that's 2 layers per coil. I'm only getting 2.4 ohms per coil, which is okay. I can deal with that. But if you want to do a stock style, you'd use the 28 gauge and 20 millimeters, and you should be able to wrap 2 layers per coil and get 4 ohms. So, I mean, I can show you that most likely, as long as I don't have trouble by using only one hand here. Alright, get this one in this hand. Alright. Get this green one over here. Alright, I got them almost touching. There we go. So, and then with any multimeter you get, so it says 2.7. So now, if I touch the multimeter leads together themselves, 0.3. It's off by 0.3. So I just subtract that from the 2.7, and I get 2.4 ohms, and that's per voice coil. So it's going to be dual voice coil, 2.4 ohms. And then on top of that, so normally you'd run at 4 ohms with the 28 gauge and two dual voice coils. This right here, let's see if I can zoom in on this thing without. That is a thermistor. It's a temperature sensor called thermistor. And I got fucking right up by that coil, and I epoxied it on. It's glued on good, and I got it wrapped with this. This is high temperature tape. It's called Kapton, I think. It's for making transformers and stuff. So all I did was I get that flashing from Ace to make the coil former, and I get the wire from eBay from Remington. And then what you do is you want to use the high heat version, because when I use the regular kind, and I laid it on way too thick my first try, and I actually was pounding the crap out of this thing after I rebuilt it for quite a while, but eventually the epoxy had turned black and into drips and was dripping down. I had like way overheated that epoxy, and I had way too much epoxy on in the first place, and it was like dripping down. It was all black with black drips, and that drip stuck out far enough to catch and pull some of the wire off and stuff when I finally overdid it. Yeah, so that stuff can't handle the temperature and will screw you over. So what you use is this high heat stuff, this JB Weld high heat, and that converts to like 260C. And as thin a layer as you can, but enough that you know it's going to hold it. And what you just do it by hand. You find just something that basically your back end, and you wrap some layers of masking tape to give it a little bigger size. Zip tie it on there and you get your thing cut out to where it's going to go in the circle good. And then you tape it or zip tie it to hold it in place. And then you start winding it with a layer of this on. And you want just a little bit of this, the epoxy, on each layer, and get them, to where it can stick. That's all you're getting. But the good thing about using the high heat stuff compared to this stuff is this stuff takes, well, it says it could take up to 24 hours to cure, but really you got like a good hour to where it starts hardening up. So you got a good amount of time to wind it, not enough time to wind the whole thing. So it's a little tricky. You can't do both coils in one shot. It'll start to get stiff on you. So what I did was the hardest thing to do is getting it started and making this transition back. So I'd get it just started, just a little bit, and then I'd let it cure and dry enough to where it ain't gonna fall apart on me. And then later on I'd come back and I'd start from where I was and then finish it up. And then once I got here, I would get it to just the end and go back, started just a little bit, and then I'd let it cure, then I'd go again, because it's making that start and then the backward motion is the hardest part. You'll have it wanting to unwind on you, and you're losing track of it, and your stuff's getting hard, and it's just a pain. And so what you do it in steps, that way. Because even with the hour or whatever this stuff takes to cure, it starts to get there pretty quicker than you'd think. And but it is nice to have over an hour instead of the 5-10 minutes, 15 minutes this stuff had. And so once you got it wound, you do it nice and slow by hand on whatever you're using to hold it. And you just do it by hand, and you're working it in, and you're doing it real nice. Then once you're done, you don't have to use the lengths wire. You want to use something nice and thick, but multiple strands, and in a way that'd be a little bit flexible at least. And you don't have to use that special wire because you're not doing high frequencies. You're doing bass, So that's low frequency. You don't need the lengths wire, because they use the lengths wire for the skin effect of the wire, and that happens at higher frequencies, and we're not using higher frequencies. So yeah, I put my fucking temperature sensor right up here by the coil, and I got each thing. I really wish I had higher temperature solder for those connections, but I don't even know what temperature the stuff I got uses. They don't really say much about that anymore. But yeah, once you got that done and rewound your voice coil, and you extracted these super hard to get out bolts, then you've got, you can get rid of the old voice coil former and just crush it in and pull it out and make your own. And then the original ones will have like these air vents which are kind of important. And oh yeah, I forgot to do that. I put the air vent holes in very carefully. And but this last thing I did was I got this glued together, and it's not quite cured yet, but I put this tape over here, and I was going to cut through and cut those holes out, and I forgot to do that. But that's so that once this moves past a certain point, it'll like allow the air to flow in between. So you want to put that back in, and then you just line up your. And the thing is this goes on top of here, and if I put it on there, I'll never get it off. And then this goes from the bottom, so you got magnets in between, and you got this gap right here, which I hogged this out a little bit to make it a little bit bigger, because it's a pain, real tight fit, and it's a pain, and I was wanting to try several different configurations that are thicker and stuff, so I hogged mine out a little bit. But so you got it like that, and you got the magnets in between them. So, but really, the magnetic field goes in between this gap, and that's the only place it's like formed to go across that gap. All that magnetic field is right at this gap, and this gap is the most important thing, apparently. So you want when it's going to stay at the spot of the gap, because that's where the magnetic field goes. So your halfway point in between your coil, you mark, and you go up just half of this thickness. So you want your resting point at the middle of this coil to be at the middle of this plate thickness, and that's what your resting point should be. And then you're good, and it'll go up and down from there, and then you see it goes past that hole, and then it comes back out of that hole, and that might create a pumping effect that helps move air. I'm not sure, but that's probably why they put it on there. Now this is still a little wet, so I don't want to mess anything up too bad. But yeah, I found that I keep forgetting that you gotta put this ring top plate, they call it. You gotta put this on first before you put the coil in, because it's much easier to get to these bolts going in from here than trying to go in from here only. So I'm going to do that before I glue that in, and I just use regular epoxy to put it into here. I don't need the high heat stuff. But then once you got this plate on with your new bolts, then you put your magnet on with just a little dab of glue of some sort that you can eventually get off. Because I forgot to tell you that part. Once you get this thing apart, this bolts out, then you got the magnet and the back plate, and they're glued together, and you got to figure out, how do I get this thing apart? Because there's a little tabs of glue in between here and the magnet. Oh, and if you didn't notice, I'd had two of these speakers, and to make it a double magnet speaker, I just took Sawzall and cut one off from the other one, back plate, and then I just glued it on. So it reaches all the way, right? Because if you really look into where the magnetic field goes, it follows up in between this gap, and that's where it's going to go. So you got to have this center thing go up all the way to here when you convert to a dual magnet. So that's why I've got it doubled up like that. And I just glued it on. It's a pain to get straight. I didn't get it straight the first time. That was half the reason why I had to redo this. But okay, now what am I missing here? So yeah, okay, now once you got your bolts on, and you put a little dab of glue, and you get your magnet in place, putting this back plate on, you do this at the same time as you do put the coil in. So you put this coil right in place and ready, and with this glue ready, and then at the exact same time you come in with this, and you use this to align everything as it's being glued in, so this coil gets glued in straight as compared to this, because this is the main thing here. Once you get this on and everything, that has to be perfectly aligned with this so it doesn't scrape. You want it to go up and down without scraping, and because the magnet is going to be pulling on this all different ways, it can be a real pain in the ass, and you might have to try it a couple times. But you'll figure it out. It's kind of really a pain, and yeah, so you have to feel it, and you push on it, pull on it until you get it in the right centered spots where it's nice and loose, and you usually catch it at the last minute before the epoxy's hard enough, but it holds it so the magnet doesn't scoot it over. It's a real pain. But okay, from there, so that's how you get this thing centered and aligned and glued in, is using the whole time period when you're putting this in, and it's a real pain. But to initially get this apart, because the magnet is glued onto here, and this is actually glued onto the magnet too on the other side of this. So to get this shit apart, what you do is, oh man, I don't think I got any. I tried this adhesive remover and it didn't do worth a crap, but I only tried it because we ran out of lacquer thinner. Lacquer thinner works better than this adhesive remover crap. And I just found a certain bowl that was this, about like a bowl like this, to where I didn't have to put it super deep. And it was about the roundness of this. And I just, lacquer thinner, filled it up to where it was over top of the section where it's glued, and let it sit. It went and did something else for a couple hours and came back and very carefully pried them apart without shattering the magnet or nothing. I just got the glue to come off, and then, like, say the one that I used the lacquer thinner, or no, the adhesive remover, and that adhesive remover didn't work worth a crap. And you usually got to use screwdrivers, like little tiny screwdrivers, and pry it up and get it to come loose, and work a razor knife all around it to get it to come loose. It's a real pain, but I'm going to show you something here. This last try, when that adhesive remover wasn't working worth a crap, we have a bunch of these at work. These are they're actually carpet blades. And we always end up with a bunch of them. They're all used and worn out and stuff. And I stuck this in between there and took a hammer and hammered on it real carefully. And I get it to break apart way. Well, when the adhesive remover wasn't working worth a crap, and I was still able to get it started and to split apart and all that by using this. It's very dangerous. You cut your damn finger off. But I was able to do it, so that helped out. But if you got lacquer thinner, that's better. Just let it sit in that for a couple hours, and that glue will be just done for, and you can just slip a razor knife in there and then pry it apart with screwdrivers and smash your fingers a couple times, because this thing grabs on everything. And if you're gonna grind that out a little bit, you don't want to go too far. I probably went too far, but then you get metal shavings that stick to this everywhere, and you can't get them off for nothing. Metal shavings all up on your magnet. What you do is you use an air compressor and a fucking air hose and just blow it off with a real powerful air hose, and you'll get all the little fucking metal shavings that have been stuck to this. You get it off. You'll never wipe them off any other way. But yeah, that's how you do it. I know this video is getting kind of long. See, and then my temperature sensor, I'm going to have come back to, because on my amp I installed these fans. I just think it needed it. And then I got a microcontroller that controls the relay to turn the fans on when it gets too hot, and and keep track of the temperature. And the temperature sensors go down here on the heat rail right by the transistors. So I'm just going to put another one of these terminals on here into a pin, and I'm going to run the temperature sensor wire to this and have this monitor the speaker temperature also. It's no big deal. See, I'm more into, I'm not really into building these speakers. I want to build the amp. I want to build Class D amps. I ain't got a whole lot of time to explain, I guess, but like here's my test rig. I never got a chance to even work on it yet. I got some really high power MOSFETs. Those are they're good for 550 amps, or no, 550 watts at 0.005 ohms. And then you see them little donut coils in there, the little bitty guys. They're so cute. This is gonna be this is my transformer. This is what I'm talking about. Each one of these is one wire, even though it's 12 strands of, I forget what, 14 gauge or 16 gauge, probably 14 gauge. This is the beast of a transformer, and then it's going to be switched by some powerful ass, real efficient MOSFETs, and then you talk about diodes. This is a diode. Actually, this is two diodes in a little package. It's got this damn heat paste that gets everywhere. I just happen to get a good deal on a couple things. It's these and the MOSFETs. These are these IXYS modules. Yeah, whatever. They're 100 amps of. And they're not just diodes. They're what do you call those? Schottky diodes. These are Schottky diodes, super fast diodes. They're made for 100 amps. And this is probably the MOSFETs I'm using. Let me see if they are. I can't see that. Because the MOSFETs are IXYS. And the MOSFETs are whatever that says, 200 amps. I think they're only 100 volts or something. But they're going to be switching the battery voltage. But yeah, these are rated at 550 watts each. And yeah, I haven't got to that because I got too many projects. So I hope you learned how you want to rewind your voice coil in a subwoofer that is blown out, or if you want to play with modifying it with double speakers. See, the first time I rebuilt this one, I did it like stock, but I did use the lower temperature stuff, and I should have used this. And, it was a pain. But once you got them screws out, rebuilding it, you can rebuild it over and over, and it'll be a lot less of a pain. And you use this high temperature stuff, it takes like an hour to set, and it's supposed to not be fully set for 24 hours. That helps out putting stuff together because nothing goes right and it always takes too long. So hope that gives you an idea. I know a lot of baskets are different than this. This is the only one I know for sure that can be done. I'm sure there's ways of doing other ones, but there might be different trick than just cutting this out with a Dremel. I'm not sure, but these are, I am sure of. These are this common basket that many speakers use, but it just happened to be these banks. What the heck? Audio bank. Yep. So yeah, I'm gonna end this video, but hope you learned something you needed to know. All right, later.